How can the temperature on Saturn be hot enough for it to rain diamonds when the planet's so far out from the sun? The answer: because of the insane pressure. We call planets like Saturn gas giants, but they do have solid surfaces underneath thousands of miles of gaseous atmosphere. And there is so much of this gas that it makes an insanely high pressure at the solid surface. This not only provides enough pressure to produce diamonds, but all of that pressure also creates a lot of heat. Indeed, a planet does not have to get much bigger than Jupiter before it becomes a brown dwarf, at which point the gravity is high enough that it is undergoing a small amount of fusion, and is basically also a weak star. Pressure is required to make the diamond, but the heat is from several sources, the most important of which is the heat that was generated when all the tiny bits of stuff in space crashed into the growing mass that eventually became Saturn. Even Earth, a much smaller planet, so had a lot less captured space material, is still really, really hot down under the ground from all that heat. It takes a very long time for heat to escape through several thousands of kilometers of ceramic-like rocky materials. The basic idea is that energy of motion, flying space debris, converted into heat energy when the bits crashed into the planet and stopped racing around the solar system. This is kind of like how car brakes get hot when used to slow the car down, or how a frozen asteroid can melt rock when it strikes the ground. All those seas on the moon are examples of that. Second, heat is being generated by tidal friction, mostly with all the many moons. Third, heat is generated by decay of radioactive elements captured with the rest of the materials making up the planet. Both of these heat sources are just delaying the cooling of the planet, which was already pretty dang slow in the first place, rather than causing the planet to be wicked hot. The main point is that Saturn was once way hotter than it is now, but its outer portions have managed to cool down. Deeper down, the heat had to wait for the outside to cool before it could even begin to migrate toward the outer surface, which it is doing right now, although very slowly, and will be doing so for as long as the planet still exists, probably. The planet will likely get destroyed by sun explosion before it converts into a huge ice-cold mass through and through. Follow this channel for more Santa Explains. And if you have any questions I should answer, just write them down in the comments.